Good evening, Chem Kids. I'm going to walk you through how to do a limiting reagent problem. I went ahead and I picked this equation because the ratio is simple, 1 to 2, and it deals with elements like carbon, hydrogen, and oxygen that we know very readily and easily what the masses are. The first thing is to realize that it is a limiting reagent problem, and that's because they gave us 16.8 grams of CO and 1.78 grams of H2. So whenever they give you two reactants, that's how you know you have a limiting reagent problem. Also, they're always going to want to know about the product. So our job is to eliminate one of these two, the one that's going to run out first, and then use that one to calculate our product, CH3OH. As always, we're going to begin by turning grams into moles. We're going to convert 16.8 grams of carbon monoxide into moles of carbon monoxide, 1 mole of CO. CO weighs, carbon weighs 12, oxygen weighs 16, and 12 plus 16 is 28 grams of CO. When I put this in the calculator, 16.8 divided by 28 to 3 sig figs, my answer is 0.6, but then I have to add 2 more zeros so that I have 3 significant numbers to my answer, 0.600 moles of CO. I'm now going to do the same thing to hydrogen. I'm going to take my grams of hydrogen, which is 1.78 grams of hydrogen, and I'm going to turn those into moles. 1 mole of hydrogen weighs 1, so H2 weighs 2.0 grams. So I'm going to be dividing 1.78 by 2 and getting 0.89. Again, I have to add a 0 to get 3 sig figs. I now have everything in moles. The 16.8 became the 0.600, and the 1.78 became the 0.890. We're now going to put this information in a way that we can keep track of what's going on, and that's by putting it in the molar box. Remember that the first part of the box is have, and the second one is need, and this box is going to help us keep track of the fact that carbon monoxide and hydrogen are dealing with each other in a ratio of 1 to 2. And we're getting that from this equation here, 1 to 2. That's how they're relating. All right, so my two reactants are carbon monoxide and hydrogen. And it's important that you realize that in this box, you have to put how much you have in moles. So remember, the carbon monoxide was 0.600, and the hydrogen was 0.890. All right, now, remember that the equation looks like this. CO plus 2H2 going to CH3OH. And this was a relationship of 1 to 2. Our job is to find out what the ratios are in this box. So carbon monoxide is 1 to 2, so we're going to put that here. And hydrogen is 2 to 1, which is the reciprocal of 1/2. We're going to put that here. And the important thing is to realize that we have to crisscross these ratios. So we're going to be taking 1/2 of 0.890 this way. 1/2 of 0.890 is going to be 0.445. And then we're going to take twice of 0.600. 0.600 times 2 is 1.20. All right, now we're going to step back and we're going to take a look at what we have here. And what this box says is that we have 0.600 moles of CO, but we only need 0.445, which means we have what we need. In fact, we have excess. And for hydrogen, we have 0.890, but we need 1.20. We don't have that. So this is the limiting reagent. The limiting reagent is the hydrogen. All right, now what do we do with this information? We cross out everything out that is not the limiting reagent. This is the limiting reagent. So we're going to start with 0.890 moles. Remember, it's moles because we're getting it off the molar box of hydrogen. And looking back at our equation, now that we've eliminated CO from being the limiting reagent, from not being the limiting reagent, it's between hydrogen and CH3OH, and that ratio is 2 to 1. So now we're dealing with these two. The ratio is 2 moles of hydrogen, the denominator, and 1 mole of CH3OH. We're going to cancel moles of hydrogen, and then we're going to get the molar mass of CH3OH. That's 12 plus 4 H's plus 1 oxygen is 16. That weighs 32 grams of CH3OH. That's 1 mole of CH3OH. All right, so to finish off this problem, we're going to be multiplying 0.890, which remember is 3 sig figs, times 32 divided by 2 is 14.24, but remember, I only need 3 sig figs, so that's going to become 14.2 grams of CH3OH. And that is my final answer. Now, there's one more thing we want to calculate, and that is how much excess. The excess, remember, was the CO right here. So you take what you have minus what you need, which is going to be in moles, and then you convert it to grams. So we're going to have 0.600 minus 0.445. 0.600 minus 0.445 is 0.155, and remember that that's in moles. So I have 0.155 moles of my excess CO, and I am simply going to turn that into grams by getting the molar mass of carbon monoxide, which is 12 plus 16, which remember is 28 grams of carbon monoxide, and 0.155 times 28 is 4.34 grams of CO, and that is equal to how much I have. That is my excess. Remember that after a limiting reagent problem, there is none of the limiting reagent left over. After the limiting reagent is used up, the reaction stops, and you can always calculate your excess by using the molar box, what you have minus what you need, and then you convert to grams. All right, Chem Kids, I'm available still by email. I'm still up. I hope this helps, and I will see you tomorrow.